All right, you guys, last year in 6th grade, you learned how to do one-step equations. So that would be something that would look like 2x equals 10, or x plus 1 would equal 6. So you would only have to do one step to solve that. In 7th grade math, you actually learn two-step equations. So I want to go through some vocabulary. First, a coefficient. It's a number adjacent, which means right next to the variable. So if you have 2x, what would your coefficient be? Does anyone know?
10, because you just now said it, or on the last one, or?
For this one right here, if a coefficient is a number right next to the variable, what would the coefficient right here be for 2x? Yes, ma'am? What do you think it would be? What number is right next to the x right here?
2.
2. What if I had negative 5x? What would the coefficient be?
-5.
Very good. Okay. So our variable is an unknown that we're solving for. Usually we see x, but could it be something like 2m?
Yes.
Right. And then a constant is the amount that's being added or subtracted. It has no variable. This is also a number. I can say it's like a number by itself. So if I have 3x minus 4, the 3 would be a coefficient because it's in front of the variable. X would be my variable. And this minus 4 right here would be the constant because it was by itself. And then we have inverse operations, and these are values for operations that we use to create a zero pair or to reverse the operation. So what would the opposite of addition be?
Subtraction.
Very good. And then what would the opposite of multiplication be?
Division.
Very good. And then we have a reciprocal, which is a value that equals 1 when you multiply. This flip, what that means is if I have 2/3, the reciprocal of 2/3 is really 3/2. So do you see how we flipped that fraction?
Mm-hmm.
So what would the reciprocal of 1/2 be?
2/1.
2/1, which isn't that just 2?
Yeah.
Good. Very good. Great. So the first thing that we're going to do, did y'all learn with algebra tiles last year when you looked at equations?
I know.
No, you don't know?
I don't think so. Oh, wait.
Well, these little, I like to call them little French fries. The green one represents a positive x. The red one is a negative x. And these red and yellow, they're almost like our integer chips, where yellow is a positive one and red is a negative one.
Okay.
So if I want to model this equation right here, 3x plus 4 is equal to 10. That's a positive 3x. So how many of the green skinny fries will I need?
3.
Good. I'm going to come over here and I'm going to add them. I need 3 of them, so I'm going to clone it. Oopsies. Great. And then it's plus 4, so that positive 4 will still be on the left-hand side. So will I need a red or a yellow?
Yellow, because isn't yellow positive?
Very good. Yellow's positive. And so how many yellows will I need?
4.
Good. Oopsies. Sorry about that. Here we go. I want to clone that, clone it. Good. So over here I have 3x plus my 4 is equal to, and then over here I have a positive 10. So how can I represent a positive 10?
Using the yellows, we got some 10 yellow.
Yes, very good. 10 yellow. All right, so that's 10 of them. We're going to move them over so they're not as crazy again. So my goal is to get one X by itself. So right now I have 3 of them on the left-hand side with a positive 4. Well, I need to get rid of the positive 4. So think of like integer chips. What's the opposite of a positive 4?
A -4?
Good. So because I want to cancel them out, I want to create 0 pairs. So if I create right here, and I negate that because it needs to be a -1. Do you see how this right there would create a 0 pair and cancel out?
Mm-hmm.
So I need 4 of them to cancel out all of these. And if I added 4 negatives to the left-hand side, what should I do to the right-hand side as well?
The same thing?
The same exact thing, because when you do the other side,
I think big Ashley's because Ashley's is
You did
doing is 7.
all right, very good. So now, this is a 0 pair, that's a 0 pair, this is a 0 pair, and so is this. I've canceled 1 over here, this one, this, and that. So I have now 3x is equal to 1, 2, 3, 4, 5, 6. Right? Does this kind of look like what you did last year? 3x is equal to 6?
Kind of.
Good. Okay, so I'm going to get rid of these 0 pairs now. Let's see if I can get rid of them. Sorry, y'all. Right, that's 4, 5, 6. Okay, so now I have that 3x is equal to 6. But I only want to know what 1x is equal to. So can I share these ones equally with each x?
No. Because, no.
No, let's see.
Maybe.
If I do,
Oh, yeah. Two ones on each one, or 2 each.
because that would share evenly, right?
Yes.
So now that means that each 1x is equal to how much?
It'd be 2 equals.
1 whole x would equal a positive 2.
Yes.
So what we did, if we look at it just by steps, that's good. If you put a 10. Oh, Control Z. There we go.
There we go.
4 equals 10. That looks better. Right. We added 4 negatives, which is the same as subtracting, right? And we added them to both sides. So we created a 0 pair. And then I had 3x, and it was equal to 6. When I separated all of these into 3 groups, I'm sharing equally. If I'm sharing, isn't that division?
Yes. Or sharing them equally into each one.
Yes.
Yeah.
And I shared equally into how many groups? I had 1 group here, 1 here, and 1 here.
3 groups.
Good. So I divided both sides into 3 groups. And I got that x was equal to 2. You see how what we did over here with the math over that matched what we did with the algebra tiles?
It does match, yeah.
Okay. So now we're going to look at a second example. And think of what we did with the algebra tiles. We moved the constants first. So if I'm looking at this equation, -5 is in front of a variable. So that's a coefficient. I have -6, which is a number by itself. So it's a constant. And I bet it equals 10. So I'm going to draw my line to separate the equation. I want to get the x by itself. So I'm going to move my constant first. So instead, I have the -6 right here. To cancel it out, I will add 6 because that is the inverse operation. And if I add it to the left-hand side, what do I need to do to the right-hand side?
Add
The
it.
same thing.
Absolutely. So a -6 and a +6 creates that 0 pair. So now I have -5x is equal to 10 plus 6, which is 16.
Okay.
Well, now x is being multiplied, and I know that I solve equations using inverse operations. So the inverse operation of multiplication would be what?
Division.
Division.
Absolutely. So if x is being multiplied by -5, then I need to come over here and divide by -5. So -5 divided by -5, that gives me a 1. That simplifies. So now I just have 1 positive x. And I need to divide 16 by a -5. When you have a positive number divided by a negative number, that will give you a negative solution. So I'm going to divide 16 by 5. How many 5s fit in 16?
3 of them.
I don't know what I just did with my
15.
fingers. Just don't mind my
Three.
fingers.
It can go in there, but it would equal 15. Okay.
All right, so now there's 1. So I'm going to add my decimal, 0, break it down. How many 5s go in 10?
Yeah, 2.
Good. So x was equal to a -3.2. Do y'all have any questions on that one?
No, that seems straightforward. And I think, yeah, we learned that.
Just
At least I learned
zero.
that in this spring's class. So
Okay, good.
I understand it.
Now we're going to look at this one. So I need to draw my line because I always want to make sure I know the left hand and the right hand side of the equation so that I keep it balanced. I have 10 minus 2x is equal to -12. What constant do I want to move?
Oh, the 10, because the 10 is the constant. So you have to move the constant.
Absolutely. And right, is the 10 positive or negative right now?
It's
Positive.
yeah.
It's positive. So how will I cancel out a positive 10?
Add negative
-10.
And if I subtract 10 on what? Oh, that does not look like a 10. If I subtract 10 on one side, what do I do to the other?
The same thing.
Absolutely. So 10 minus 10, that cancels out. That creates a 0 pair. What is left on the left-hand side of the equation now?
Oh, plus or negative, don't they add up together? So it would be 22. Negative 22.
-22 will be over here. So what's left on the other side though?
2x.
Almost. You see how it's a minus?
-2x.
Oh,
Right.
negative 2x. Okay.
That negative sticks with it.
Yeah.
So now x is just being multiplied. What's the
Oh, I
inverse
was about to put an
multiplication?
8. Division.
Right. So if x is being multiplied by -2, I need to go and divide by what?
+2.
If I divide by a +2, is that going to cancel it out with 1?
No.
No. I want to divide by the negative.
I knew that.
Whatever it's being multiplied by is what you want to divide by. And if I divide by the left-hand side, I also need to divide on the right-hand side.
No.
So now -2 divided by -2, that does make it 1. So I have x is
1.
equal to, and it's a negative divided by a negative. So will my solution be positive or negative here?
Positive.
Good.
Yeah.
Positive.
And what's 22 divided by 2?
11.
Oh, yeah. 11.
-11.
Negative.
Yeah.
Ooh, it's going to be positive.
Oh, yeah.
Remember,
Paper.
I'm trying
when
to
you're
think.
multiplying or dividing, if you have the same signs,
Okay.
they're positive in solution. And if you have different signs, they're not positive, which means it's negative.
Okay.
So right here, we had a -22 and a -2. So we had the same signs, which is why our solution was positive.
Yeah.
for this problem here, we had a positive divided by a negative. So they were different signs, which means my solution was this negative 3.2. Do you have questions on either one of those so far?
Nope.
Awesome. All right. So now we have 1/2 x plus 6 is equal to 28. So I draw my line. Now, what do you think the first thing I want to do is?
Oh, the 6. I forgot what it's called, but
You're right. It's the constant.
put a -6 on the
And if I do it to one side,
do this other side.
okay. So a positive 6 and a -6 creates a 0 pair. So now I have 28 minus 6.
It would be
22.
Very good. All right, now let's think about this. I have let's make that actually look like a 22. There we go. I have 1/2 of x, and that's 22. I don't want 1/2 of x, I want 1 x. So if I like drawing pictures. Do y'all mind?
that's fun.
So right now, I have 1/2 of x right here. And I know that 1/2 of x is equal to how much? If I'm looking at my equation right here, 1/2 of x is equal to how much?
Oh, 22.
22.
Yeah.
So I'm going to put 22 right there because I know 1/2 of x is equal to 22. It takes 2 halves to make 1 whole. So this other second part of my rectangle is also a 1/2 of x, correct?
Yes.
Which means what value goes inside of the box?
22.
Absolutely. So 2 halves gives me 1 whole x. So 1 whole x was equal to how much over here?
44.
Yes. Which really, it's kind of like I just doubled it. Because if you have half of something and you double it or multiply by 2, that gives you 1 whole. And if you multiply by 2 on one side, you would multiply by 2 on the other to give you 44. Do y'all see how the picture translates to the equation, or does that not make sense?
Yes.
Okay. Let me know if I'm going too fast, okay? All right, now I have x, and then what does that little slash mean? What operation is that? Do you guys know what that means, the slash?
I would think it would mean a fraction. but-
Division?
It does. Well, I could also rewrite it over here as x over 8 minus 1 is equal to 4. So
Okay.
you are very right. That is a fraction. And fractions are what operation?
Division.
Correct. So I'm going to draw my line here. And what constant do I want to move?
The -1.
Good. So if I add 1 to the left, why am I adding 1 and not subtracting 1?
Because it's a -1 that you're adding the positive one to.
Absolutely. So if you subtract if you add to the left side, what do I need to do to the right side?
Same thing.
Awesome. So that will cancel out. So now I have x divided into 8, and that would equal 5.
Okay.
So do I have a number in front of the x? Or is it just x divided by 8? That's really saying 1/8 of x. So x divided by 8 is actually the same thing as 1/8 of x. So if you think about what we kind of did on that last example, if I did draw a rectangle, how many pieces do I need to cut my rectangle into?
8.
8.
Yes, ma'am. 8, because it takes eights to make one whole. Let's see, did I count right? 1, 2, 3, 4, 5, 6. Good. And I have, right now, I have only 1/8 of x. And I know that 1/8 of x was equal to how much over here?
5.
5.
Good. So 5 goes inside. So what number keeps going inside each of the rectangles?
5.
5.
Oh my
How many
gosh.
groups of 5 do I have right there?
8.
8.
8.
8 groups of 5. So really, I can multiply by 8 here. And I get 8/8, which I know is 1 whole x. And it equals, well, what's 5 groups of 8? Or 8 groups of 5?
40.
45. 40.
40. Oops. Make that look like a 40. 40. So x is equal to 40. Do y'all have questions about that?
No.
No.
Okay, so I am going to stop sharing my screen. Let's see. Okay. I'm going to come back. Oh, hi guys. I didn't realize everybody was all here. And then I want to show you all one more example when our numerator is not 1, okay?
Okay.
Then I'm going to change the screen. Switch again. Here we go.
Okay.
Can y'all see if I put
That's my notebook.
can I see if I put my paper right there?
Mm-hmm. You
It
can see.
Is it too small or is it just right?
looks just right. I mean, you want me to write on it so I can see if it's.
Okay. So I'm going to say, let's say we have 3/7 of x.
You might want to pull it down a little bit. Oh, there we go.
Oh, there we go.
There we go. Is that big enough?
That's good.
Yes.
So 3/7 of
I
x
got my 10 bags.
plus 4 equals 13. Okay. So if we're treating this like we did the other ones, I would draw my line and I want to move my constant.
Okay.
So
Okay.
which one do you want to get rid of?
The 4. Positive 4.
Good. And if it's positive, how do I cancel out a positive 4?
A negative 4.
Negative.
And if I subtract 4 on one side, what do I need to do on the other?
The same.
Yeah.
Is
Good. All right. Positive 4 and negative 4 become a 0 pair. So everything that I have left over is 3/7 of x equals, what's 13 minus 4?
9.
No.
Good. All right. This one is different than the other two that we did because my numerator isn't 1. So now if I draw my rectangle, can you guys see that rectangle?
Mm-hmm.
Okay.
yes.
I have 3/7 of x, which means I need to cut my rectangle into 7 pieces. 2, 3, 4, 5, 6, and 7.
Trying to get.
So I have 7 pieces right here representing each 1/7 of x. But when I look here, how many sevenths did I actually have of x?
3.
3.
3. So I actually have 3 of these guys right here. So that represents my 3/7 of x. And I know that 3/7 of x was equal to 9.
Mm-hmm.
So how can I share 9 into these 3 boxes?
By putting 3 in each one.
Absolutely. And I'm equally sharing here, right? Which is division.
Mm-hmm.
And I divided it into 3 groups. So if I look here, technically I divided by 3 on both sides. Well, 3/7 divided by 3 gave me just 1/7 of x, which was 3, because 9 divided by 3 is 3. So what goes in each one of the rest of the rectangles?
3.
Absolutely. And how many groups of 3 do I have right here?
7.
7. So that's really 7 groups of 3. So that means I'm multiplying by 7, which means 1 whole x is equal to how much?
21. Okay. The spring keeps going away.
What do we think my 1 whole x equals right here?
21.
Oh,
21, right? 21.
Oh.
Do you see how we divided by our numerator to get to a unit fraction right here? And a unit fraction is just when your numerator is 1. Because if I know what 1/7 of x is, I know I need 7/7 to get to 1 whole. Do you guys want to try one more like that for practice?
Yes.
Sure.
Okay.
Oh, my pen broke. Oh, wait, no, my dog ate it.
Helpful. All right. Let's say 2/5 of. Could someone give me a letter that's not X?
A.
M.
Oh, I wrote A. Oopsies. 2/5 of A. Plus.
You might want to pull it down a little bit.
Oh, thank you.
Yeah.
There we go.
2/5 of A plus 5 is equal to -7.
Okay.
So if I draw my line,
Wow.
what's the first thing I want to do right here?
The +5, put a -5.
Absolutely.
Then
Make,
you zero.
they zero each other out, and then you do the same to the other side.
Oops, I go back up. All right. So I'm left with 2/5 of A, on the left-hand side. And then on the right-hand side, I have 7 negatives here, and I have 5 negatives here. How many total negatives is that?
-12.
Good.
-12.
So I have 2/5 of A is equal to -12. Well, I have 2/5. So if I'm drawing my rectangle, how many pieces do I need to cut it into?
5.
5.
1, 2, 3, 4, 5. Good. And let's pretend like your teacher knows how to draw evenly. How many fifths of A do I actually have?
2.
So I only have
2.
these 2 right here. So that represents my 2/5 of A, which I know is -12. So how can I split the -12 evenly into these boxes?
You put
-6 on each one.
Good.
6.
-6 and -6. Which means really what I just did right there is I divided by 2 to find out what 1/5 of A was equal to. And it was equal to -6. It will take me 5/5 to get to 1 whole, which is what each one of these represents. So what number goes in each one of these?
-6.
Good. And how many -6s do I have?
5.
5. So I technically could add them all up, right? But repeated addition is multiplication. So can I just multiply -6 times 5?
30.
Oh, yeah. That's
So I will multiply by 5. So 1/5 of A times 5 gives me just 1 whole A. And -6 times 5 is what?
-30.
30.
Good. Does it make more sense after seeing it a second time?
It does, yes.
Yeah.
Okay. I'm going to and pen. Start recording. All right.
We'll go with that.